Hello everyone. In this video I'm going to teach you about binary search. So let me introduce myself. My name is Pawan Kumar Giri and this is going to be a demo video. So let's get started. So binary search is one of the most important algorithms when searching algorithms, one of the most important searching algorithms when you are preparing for any type of exams. Let it be like interview preparation, online assessment preparation, anywhere you will find like problems based on binary search algorithms. So what basically is a binary search algorithm? So if you notice the name, it has two parts. One part is binary and another part is search. We all know what is search. Search is basically normal searching, like finding, and binary means two. So we'll see later, like as we move ahead, how this algorithm works. We'll find out like why it is named as binary search. Okay, as of now, let me jump you directly to the working, like how this algorithm works. Okay, so before moving to that part, we need to understand that this algorithms works on sorted arrays. Okay, so I hope that you all know what is an array. Array is basically a data structure for storing elements, as you have known by the time. Like array is one of the basic data structure that you need to know before getting started with binary search. So now what is meant by sorted? Sorted means your elements are either in increasing order or in decreasing order. One example of increasing order is 1, 2, 3, 4, 5. Obviously, increasing mean as we move ahead, the element should be either greater or equal, not to be less than the current element. Okay, that's increasing. And what is decreasing? So as we move ahead, our values should decrease or be equal, but not greater. Okay, 5, 4, 3, 2, 1. So it should follow this pattern. So whatever array we have, it should either be increasing or decreasing. So how our algorithm works in sorted arrays? Let me give you like working principle behind this algorithm. Okay, so we have three elements or three variables, you can say. One is a start, one is a end, and one is a mid. So start points to the starting index of array, end point to the ending index of array, and midpoint to the middle element of that array. So or range, you can say. So how this algorithm works, we know. So we consider, I'm telling you about increasing order, when our elements are in increasing order, and you can do the same for decreasing order also. Okay, there is no different implementation for that. You can implement it once you understand how this algorithm works for element in increasing order. So suppose, so what we do is, in each operation we compare. So we have a value to search, like if this value is present in this array or not. Okay, so what we'll do is, first initially our start will be 0, end will be n minus 1, where n is the number of elements in this array. Okay, and mid is going to be start plus end by 2. So these all are indexes basically, and we need to check if this value is present or not. So what we do is, we compare with the middle element. So let our array be A. Okay, so we compare like with this middle element. So if this element is equal to value, it means we have found the element. So we can print like cout, element is present. Okay, so we have found the element if the middle element is equal to the value. If a middle element is not equal to value, it means there are two cases. First case, ki middle element is greater than the value. Okay, and second case is obviously middle element is less than the value. So let us consider the first case, middle element is greater than value. So what does that mean? It means all the values. So if this element is greater than value, if this middle element is greater than value, it means all elements to its right, I mean in this range, mid to end, you can see like green marking here, all elements here are also going to be greater than the element value, because this array is sorted in increasing order, and in this range the smallest value is obviously of this middle value, because as we move to the right, either the element is going to increase or equal, so they are not going to decrease. So all values in this range are going to be greater than value. So does that make sense to compare or search for this value in this range? No. So what we do here is, if this is happening, a of mid is greater than value, so we update our end. So we don't need to search from this start to this end. We already have seen that this middle value is greater than the value we are searching for. So what we'll do is, we will update our end to here, mid minus 1 basically. So now we'll check for this range. There is no point checking for value in range from mid to end, because a of mid is greater than value. So all values in this range are going to be greater than the value. Okay. So we'll update our end value. So end becomes mid minus 1. So now we also need to update our middle point also. For this start and this, for this start and this end, we need to update our mid value. So mid is going to be start plus end by 2. So let us suppose like mid is pointing here. So this is our new mid. Okay. So now again we'll check with like middle value, if array of mid is equal to value or not. If it is equal to value, it means we have found the element. If it is not equal, so there are two cases, either it is going to be greater or smaller. So let us suppose in this case, this time, so this condition is satisfied. What is this condition? Ki middle value is less than value we are searching for. So middle value is less than value. So all values to my left, from start to mid minus 1, all values in this range are also going to be less than value, because elements are sorted in increasing order. We'll see with example also. So all values in this range are going to be smaller than the value. Okay. So does that make sense to search in this range? No. Then we'll search in this range only, mid plus 1 to end. So we'll update our start. Start will be updated to mid plus 1. And mid will also be updated. Mid will be start plus end by 2. So why we do this? Because a of mid is less than value, then all values from range start to mid will be less than value. So now what we are left with? We need to check in range mid plus 1 to end. So that's what we did. We updated our start to mid plus 1 and end remains same. So for this range, we need to find our mid value and compare again. So that's how this algorithm works. So in each iteration, what we are doing is, so we are removing or discarding half of the array or half of the range we have. So we started from this whole array. We have a middle value here somewhere. So based on comparison, what we do is, if value is a of mid is not equal to value we are searching for, if this condition is not satisfied, so there are two options left. So either this value is greater than value or less than value. Suppose this value is greater than value. So what does that mean? All value to my right are going to be greater than value. So I discard half of the array. So earlier if I was searching for 0 to n minus 1 and mid was at 0 plus n minus 1, start plus n by 2, which is nothing but n minus 1 by 2. So now I will search from start to mid minus 1, because value is not going to be present in this range. So on each iteration I am discarding half of the range. So suppose I was looking for earlier, like I started with n to be 8. So on next iteration, so there is going to be two parts, 0 to mid and mid to end. So there are two parts. So based on comparison, I would discard one part. So I'll discard one part. So now I will left out with 4 elements. On next iteration, similarly, this 4 elements will again be divided into 2 parts. And again, based on comparison with mid, I'll discard one of the part. So now I will left out with 2 elements. Now again, those 2 elements will be divided into 2 parts. And based on comparison, what I'll do, I'll discard one of the part. So I'll left with n equal to 1. So what you are seeing here is on each iteration, my range is halved, almost halved. Okay. So for a size of n equal to 8, what I did is 4 operations. So like on every iteration, I am discarding half of the array. Okay, that's how you can see that this is very optimal on searching elements in sorted array. So let us take an example. So suppose we have 10, 14, 19, 26, 27, 31, 33, 35. Okay. So how many elements here? We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements here. Okay. So and let us suppose we are looking for 15. Okay. We are looking for 15. So if I write down their indexes, it is 0, 1, 2, 3, 4, 5, 6, 7. So our start will be at 0, end is going to be 7, and mid is nothing but 0 plus 7 by 2 is 3. 7 by 2 is nothing but 3. We are considering integer division. This is mid. Okay. What we'll check? So value at index 3. Index 3 we have value 26. So is a of 3 or 26 equal to 15? Nope. This condition is false. So next what we'll check? Which condition will be satisfied? We can see that a of mid here, a of 3 is greater than value we are searching for, which is 15. So 26 is greater than 15. So what does this mean? This means all value to my right from 26 to 35 are going to be greater. And we can see here also like 27 is greater than 15, 31 is greater than 15, 33, and all elements are going to be greater than 15 since the array is sorted in increasing order. So as we move to right, values will increase or equal. So there is only 2 conditions. So it's not going to decrease. So it is irrelevant to check in this range. So I'll discard this whole range. Okay. Discard this whole range. My element is not present here. Okay. So now I need to check in only this range. Start to mid minus 1. Because mid is not equal. That's why we are going for mid minus 1. Element will be present if present in start to mid minus 1. So I'll update my end. So my range will also be updated. Na? So this is going to be the last element of the range I want to compare with. So end is going to be mid minus 1 here. So this is the case when a of mid is greater than the value. In this case, I update the end part. End is equal to mid minus 1. And also for this range, what is the middle value? Start plus end by 2. So you can see like mid was 3 here. So mid minus 1 is going to be 2. And for start plus end by 2, 0 plus 2 by 2 is nothing but 1. So now this is my mid value. So we are left with 3 elements, 10, 14 and 19. So this is where start is pointing 0. This is where mid is pointing 1. This is where end is pointing, which is nothing but 2. Okay. So what's happening here? So we'll again compare with the mid value. What is the value we are searching for? 15. So we'll check. Is 14 equal to 15? No. This condition is not satisfied. So what's now? So now we'll check if a of which condition will be satisfied. In this case, the middle element a of 1 is less than value we are searching for. So what does that mean? That means all value to my left are also going to be less than 15. Yes, since array is sorted in increasing order. So this is going to be the max value in range from start to mid minus 1. So all values to my left are already going to be smaller than value if mid is smaller than value. So now what? Now look for this range only, mid plus 1 to end. Okay, so I update my start here. So this is the condition when a of mid is less than value. So I update my start. Start becomes mid plus 1, which is nothing but 1 plus 1 2, and I update mid also for this range. Mid is nothing but 2 plus 2 by 2, start plus end by 2, which is nothing but 2. So now everything like start is also pointing here, end is also pointing here, mid is also pointing here. We again compare, like, is a of mid equal to 15? Obviously condition is not true because 19 is not equal to 15. Okay, so now what? Is 19 equal to 15? No. So now what? So this is the condition when mid element is greater than value. So in this case what we do is we check in range, we obviously update our end pointer, it becomes mid minus 1, and mid is also updated. So mid was 2, mid becomes 1, and mid minus 1 is 1. So mid is now start plus end by 2, 2 plus 1 by 2, which is nothing but 1. Okay, but is it valid? So can my start be greater than end at any point? So it is never possible. So I have start index as 2 and end index as 1. So this is not a valid range. So there need to be some terminating condition also. What is that terminating condition? Where will I stop searching for elements? So I will stop when I'll get this invalid range or my element is already found. So there are two conditions where I need to stop my searching. Two conditions when I stop searching. One of the condition is here. We saw that start becomes greater than end. So this cannot be possible for a range. So this is invalid range. So for invalid range, as we move to invalid range, we stop our search. So when we'll go to invalid range? When the element will not be present. Okay, so element is not present, we go to invalid range. So what is the condition for valid range? Always start should be less than equal to end. So this is condition for valid range. So this is one condition for termination. So what is the second condition or the other condition for termination? Other condition is we have already found that our middle element is equal to value. In that case also, since we have found the element, there is no point searching. So this is our second terminating condition. So we have seen, like, either we have an invalid range or we have already found the element. These are the two conditions when we need to stop our searching. Okay, so we have seen how this algorithm works. On each iteration, what we do is we discard half of the array since elements are sorted in increasing order. Okay, so there, if I want to write down like properly, let us take a case when element is present. Okay, so this is going to be interesting. 10, 14, 19, 26, 27, 31, 33, 35 and 42. So comma separate elements. Okay, so suppose we are searching for, let's say, 35, and 35 is present also. So let's say how this will work. So if I write down the index 0, 1, 2, 3, 4, 5, 6, 7 and 8. So we have start at 0 and at 8, and mid will be start plus end by 2. 0 plus 8 by 2 is 4. So mid is pointing here. Okay, so what we'll check? We'll check, like, is a of 4 equal to value we are searching for. A of 4 is nothing but 27. 27 equal to 35. Nope, this condition is not true. So what next? Which condition is satisfied? So condition will be satisfied like a of mid is less than value. So what to do? So if this mid value is less than the value we are searching for, then this means all value to my left from start is also less than the value. So we don't need to search in this range. So we'll update our start pointer. So our start pointer will point to mid plus 1. So we'll update our start pointer. Start will become mid plus 1, which is nothing but 4 plus 1, 5. Okay, so now we have new start, and for this new range start to end, we also need to find the mid value. So mid is nothing but start plus end by 2, and 5 plus 8 is nothing but 13 by 2, which is 6. We do integer division here. Okay, so now we have a middle value at 6. So mid value is pointing at index 6. So now we compare again. So what is value here? Is 33 equal to 35? Nope, this condition is not true again. So this is also the same condition where mid value is less than value. So like 33 is less than 35, this is that condition. So what to do? We again update start. So start becomes mid plus 1, start becomes 7, 6 plus 1. Okay, so mid, we find new mid is nothing but start plus end by 2, or 7 plus 8 by 2, 15 by 2 is nothing but 7. Okay, integer division we are doing. So now our start is here, mid is also here. So we check again. A of 7 is equal to 35, or 35 equal to 35. Yes, this condition is satisfied. So this means we have find our element. Okay, that's how everything goes. I hope you understand how this binary search algorithm works. So now why we call it as binary? We call it as binary because we do partition into two groups. So this is our whole array, and I do partition into two groups at midpoints. So we have two groups. So now based on comparison, we discard one of the group. Okay, so half of the array is discarded. So earlier if I started with n, next iteration I'll be searching in range of n by 2 of with elements n by 2. Okay, next time it becomes n by 4. Next time it becomes n by 8. On every iteration, number of elements in range we are searching for is halved. Okay, so this is very efficient algorithm. Like for 1024 elements, we only need 10 operations, 10 searching operation, and we can find it. So why? Because like on each iteration value is decreased by 2. So 102, then it is like 512, then it is 256. On next iteration it becomes 128, then 64, then 32, then 16. So can you see how number of elements are decreasing? They are becoming half on each iteration. So this algorithm is very fast. If you talk about the time complexity, it is log of n, log base 2n. Okay, so on every iteration the array or range we are searching for is halved. So that's all. Now if you look about the code, like how the code works, well, as of now I would recommend you should try by on your own, but here is the overview if you want the code. So we have a start variable which is at 0, end variable which is at n minus 1, where n is the number of elements, and mid is the middle element of the array, which is nothing but start plus end by 2. Okay, so we'll start with a while loop, and this while loop, or we will continue until we have a valid range, start less than equal to end. Okay, first thing we'll do is we'll check if our middle element is equal to value we are searching for. If this is the case, then we have found the element, we can print it, element found. And we'll mark it also, like f equal to 1. So why marking it? So that we know we have found it or not. And we come out of the loop. There is no point searching again, we have already found it. Okay, so if mid element is not equal, it means either it is greater or smaller. So if a of the middle value is greater than value we are searching for, in this case what to do? So this is greater, it means all values. So here we consider a case like this. Here is the middle element. If this value is greater, it means all value to my right are also going to be greater. So we discard this range. So now our end point is updated. So end becomes mid minus 1. Okay. And we update middle value also based on new range, which is start plus end by 2. Else we have other condition like a of mid or the middle value is less than value. So this is the case where all values, like if middle value is less than value, it means all value to my left here are also going to be smaller. So we check in range mid plus 1 to end. So I update my start pointer. Start becomes mid plus 1. Okay. And mid value is updated. Mid is nothing but start plus end by 2. So that's all. That is the binary search program. So after coming out of the loop, we check if we have already found it. So if f is 0, it means we have not found it. When we found the element, we mark f to be 1. So we print cout not found. So that's all. Thank you.